This is a released exam question from May 2011. No calculator is allowed. This is from paper 1. So what we have is, this is supposed to be a triangle, and it shows an obtuse angled triangle. We're supposed to write down BA, find BC, and then find cos of ABC, and find the angle of sine of B. Just to get BA, all you're going to do is take this angle, or this vector here, and multiply it by -1. That's all you have to do. Vector BA is the opposite of vector AB, so just multiply each component by -1. So basically, BA is just going to be, you just negate everything and you're going to get 304. The second part is to find BC, and we're going to use the principles of vector geometry just to add the vectors. So BC just equals BA plus AC. So that's going to be 304 plus -2 to -6. Ooh. And then that's going to equal 1 to -2. Now we have to find cosine of B, or A, B, C. So we're just going to use the formula cos of theta equals V dot W over magnitude of V times the magnitude of W. Okay, so we're going to get this equals BA dot BC over magnitude of BA times BC. So this is going to give us 3.1 plus 0.2 plus 4 times -2 all over the square root of 1 squared plus 2 squared plus -2 squared times the square root of 3 squared plus 0 squared plus 4 squared. And this is going to give you a -5 over the square root of 9 times the square root of 25. And that equals -5 over 3 times 5, which just equals -1/3. So that's cosine. Now we have to also just infer sine. So sine is going to be, so let me write that down, sine of ABC. And I'm just going to use my formula, cosine squared plus sine squared equals 1. So we have cosine squared is going to be -1/3 squared plus sine squared of ABC equals 1. So this is 1/9 plus sine squared of ABC equals 1. And when you subtract, you're going to get sine squared of ABC equals 8/9. I just did 9/9 minus 1/9. When you square root both sides, you're going to get sine of ABC equals plus or minus, if I just want to do this, when you do square root both sides, that's going to be square plus or minus square root of 8 over 3. Okay? And that's your answer, but we're going to use the positive. So that's going to be just square root of 8 over 3. Now, we have a point D such that, so we have point D such that CD equals -4, 5, and P. And P is positive. Now, if they're telling you, given that the magnitude of CD equals the square root of 50, they just want you to show that P equals 3. So what we're going to do is just use our CD equals the square root of -4 squared plus 5 squared plus P squared. And we want P to be 3. Well, this equals square root of 50. And then when you simplify this, you're going to get 41. 16 plus 25, that's going to be 41 plus P squared. When you square both sides, you get 50 equals 41 plus P squared. You subtract 41 from both sides, and you get 9 equals P squared. So P equals 3. Okay? And so we did show that, and now they want to show that CD, vector CD, is perpendicular to BC. And we're going to use the dot product because if vectors are perpendicular, their scalar product is equal to 0. And that's a comment. You want to write your conclusion like that. Vectors are perpendicular because their scalar product equals to 0. So we're going to use the formula V dot W equals V sub 1 times dot W1 plus V sub 2 W sub 2 plus V sub 3 dot W sub 3. So we're going to get 1 times -4 plus 2 times 5 plus -2 times 3. And this equals -4 plus 10 minus 6, and that equals 0. So the vectors are perpendicular because their scalar product equals to 0. And that's all. Thank you. Have a nice day. Bye-bye.